Good morning, everyone. Time for lesson 63, products of square roots and repeating decimals, two topics that don't actually have a whole lot to do with each other, but we're going to review them together anyway. So first off, in lesson 62, we talked about roots, in particular square roots. Remember, square root, using this symbol here, indicates we're looking to find the number that if we square it, if we multiply by itself, we'll get the original number. Now, one thing about square roots, because square roots, we're looking for two things that are multiplied together. We can write them a little bit differently in a way that'll help us simplify square roots of larger numbers. So anytime that we have two square roots being multiplied to each other, that's always going to be equal to having those two numbers multiplied to each other and then taking the square root of that. It doesn't matter which order you do it in, whether you take the square roots of the numbers first and then multiply them together, or whether you multiply them and then take the square root. Those are going to be equal to each other. We'll do a couple of examples here to show you how we can use this property to simplify square roots of larger numbers. So first up, 50. Now 50, square root of 50, we run through maybe our list of squares in our heads. We say, well, let's see, 7 squared is 49, so it's not that. 8 squared is 64. It's not that either. It's somewhere between 7 and 8. It's going to end up being an irrational number, but we can get a better idea of what it is and put it in a more convenient format than this. The first thing to do anytime you have one of these is going to be to break down the number that's underneath the square root sign into its prime factors. So 50, another way of writing that is not just 50, but we could write 5 times 10, or even better, we could break it all the way down into its prime factors, and we'll end up with 2 times 5 times 5. So square root of 50 is the same as writing the square root of 2 times 5 times 5, which is the same thing as writing the square root of 2 times the square root of 5 times the square root of 5. Because it doesn't matter what order we do this in, whether we take multiply the numbers together first and then the square root, or whether we do the square root first and then multiply. Square root of 2 times square root of 5 times square root of 5. Now, square root of 5 times square root of 5, by definition, those two multiplied together will give us 5, because the square root of 5 is the number that when we multiply it by itself, we get 5. And the way we can write this is 5 times the square root of 2. Now, that's as far as we can go. The square root of 2 is an irrational number. It's a non-repeating decimal. There's no way to write it as a fraction. There's no more convenient way for us to write it than as square root of 2. But if we write it as 5 times the square root of 2, that's going to be more convenient later on when we're working with these numbers. Let's do 200. Now 200, breaking that down into its prime factors, again, not too difficult. So let's see, 20 times 10, okay? Well, 20 is 2 times 2 times 5, and 10 is 2 times 5. So we're going to have 3 2's, 2 times 2 times 2, and then we're going to have 2 5's times 5 times 5, just like that. Right, and then we can check it. 3 2's together gives us 8. 5 times 5 is 25. 8 times 25, all right, that's 200. So we can rewrite this as the product of all of these numbers, individual square roots. So 3 times square root of 2, and then 2 square roots of 5 multiplied together. Again, we can simplify here. These two square roots of 2 multiplied together and give us 2. And similarly, these two square roots of 5 multiplied together and give us 5. So what we end up with is 2 times the square root of 2 times 5, or again, we can simplify further, and we can write as 10 times the square root of 2. 10 times the square root of 2. And that's going to be a more convenient way to do that. One more example here with a number that's a bit harder to factor, 147. 147, how are we going to factor that? It looks weird. It ends with a 7, which is not very helpful. Remember, when you have a number like this that it's hard to immediately see any factors for, check whether it's divisible by 3 or 9. Remember, with both of those, what you're going to do is you're going to add all the digits together, and then if that number that you get is divisible by 3 or 9, then the number itself is divisible by 3 or 9. So 147, 1 plus 4 plus 7 is 12, which is divisible by 3. So we know this whole thing's going to be divisible by 3. And what do we get when we divide by 3? Well, we're actually going to get, let's see, 3 goes into 14 4 times with 2 left over. 3 goes into 27 9 times. So we end up with 49. 3 times 49. And 49 we should recognize as 7 times 7. So 147 is 3 times 7 times 7. Again, we can write that as square root of 3 times square root of 7 times square root of 7. And square root of 7 times square root of 7 is just going to be 7. So we end up with 7 times the square root of 3. Notice that when I've written each of these answers, 5 times the square root of 2, 10 times the square root of 2, and 7 times the square root of 3, that I've written the whole number portion first, and then the square root portion. And that's the way that you're going to want to write these, is with that whole number portion first. So again, the process is break the number down into its prime factors. Think of it as a series of squares of each of those prime factors, and then see if there's anything you can simplify there. Okay, next topic, not too difficult, repeating decimals. You might remember that when we have a decimal that repeats, it goes on forever, that there's a symbol we can use that as opposed to writing out, well, we can't write out an infinite number of decimals. And there are certain common fractions that if we convert them to decimals, will be repeating decimals. Remember, a repeating decimal, even though it goes on forever, is not an irrational number. We can still represent it as a fraction. You'll notice each of these are fractions that when we represent them as decimals, we need to repeat. So 1/3, if you divide that out, if you try to divide 1 by 3, you're going to get 0.33333. It's always going to be 3s. So we put the line over the 3 to indicate that that 3 repeats forever. Another common one, 2/3, 0.6 repeating. 1/9, 0.1 repeating, and then 1/6, 0.16 repeating. Notice it's only the 6 of the 1/6 that repeats, not the 1. So it's 0.1666666, and then the 6's go on forever. So you should be familiar, make sure you're familiar with these 4 fractions and their decimal values, these repeating decimal values. In fact, I'll tell you a little trick. Anything over 9 is going to end up being a repeating decimal. 1/9, as you see here, is 0.1 repeating. 2/9 is 0.2 repeating. 3/9, or 1/3, we've already seen is 0.3 repeating. 4/9 is 0.4 repeating. 5/9 is 0.5 repeating. 6/9, or 2/3, is 0.6 repeating. 7/9 is 0.7 repeating. And 8/9 is 0.8 repeating. So neat little trick there with ninths and these repeating decimals. All right. Again, do the odds. Please check your work. Please show me your work with what you upload to Jupyter. And stop by office hours if you have any questions.